Welcome to the presentation on derivatives. I think you're going to find this is when math starts to become
In this video, I want to familiarize you with the idea of a limit, which is a super important idea. It's really the idea that all of calculus is based upon. But despite being so super important, it's actually a really simple idea. So let me draw a function here. Actually, let me define a function here. A kind of a simple function. So let's define f of x. Let's say that f of x is going to be x minus -1 over x minus 1. And you might say, hey Sal, look, I have the same thing in the numerator and the denominator. If I have something divided by itself, that would just be equal to 1. Can't I just simplify this to f of x equals 1? And I would say, well, you're almost true. The difference between f of x equals 1 and this thing right over here is that this thing can never this thing is undefined when x is equal to 1. Because if you set, let me define it right, let me write it over here. If you have f of, sorry, not f of 0, if you have f of 1, what happens? In the numerator, you get 1 minus 1, which is, let me just write it down. In the numerator, you get 0 defined. But what if I were to ask you, what is the function approaching as x equals 1? Well, you look at this definition. Okay, when x equals 2, I use this situation right over here, and it tells me it's going to be equal to 1. Let me ask a more interesting question, or perhaps a more interesting question. We're getting to 4. So once again, that's a numeric way of saying that the limit as x approaches 2 from either direction of g of x, even though right at 2 the function is equal to 1 because it's discontinuous, the limit as we're approaching 2, we're getting closer and closer and closer to 4.